What if we are going to multiply radicals with different indices but do the same radicands? Or different indices and different radicands? To multiply these kinds of radicals, we are going to use the power rule of exponents. Let's have example number 9. Cube root of 2 times the square root of 2. First, we change them into expressions using rational exponents. So, cube root of 2 is equivalent to 2 raised to 1/3. And square root of 2 is equivalent to 2 raised to 1/2. We now simplify this. 1/2 plus 1/3. 1/2 plus 1/3 is equal to 6 over 3, that's 2. 6 over 3 plus 2, it's equal to 5 over 6. So 2 raised to 5 over 6. Then we change this to radicals. So this is equivalent to the 6th root of 2 raised to 5, or the 6th root of 32. Next, number 10. Next, we have the 4th root of 3, the cube root of 3, and the square root of 3. We are going to multiply these 3 radicals. Again, we write them using rational exponents. 4th root of 3 is equivalent to 3 raised to 1/4 times 3 raised to 1/3 times 3 raised to 1/2. Since they have the same base, we can add the exponents. 3 raised to 1/4 plus 1/3 plus 1/2. Okay, so what is 1/4 plus 1/3 plus 1/2? Their LCD is 12. 12 divided by 4 times 1, that is 3. 12 divided by 3, 4 times 1 plus 4, 3 divided by 2 times 1, 6. So we have here 13 over 12. So this is equal to 3 raised to 13 over 12. And so, the product of this can be written as the 12th root of 3 raised to 13. Next, we can still simplify this further because 13 is greater than 12. So, 3 raised to 13 has a perfect 12 power. So, 13 raised to 12 times 3. So, this expression here is just equivalent to 3 raised to 13 because we just separated the exponents 12 and 1. So, we have here a perfect power. It's a power of 12. So, we can extract it. So, 3, 12 root of 3. So, this is our final example number 11. And we have the square root of 3 multiplied to the cube root of 2. In this case, we have radicals with different indices. The index of this is 2. The index of the second radical is 3. They also have different radicands. The radicand is 3 and the radicand is 2. So how do we multiply these kinds of radicals? First, we write them using rational exponents. So square root of 3 is equivalent to 3 raised to 1/2, and the cube root of 2 is equivalent to 2 raised to 1/3. The next step is to write the fractions in such a way that they have the same denominator. So 3 raised to 1/2 and 2 raised to 1/3. How do you write them in such a way that they have the same denominators? We have 1/2 and 1/3. Their LCD is 6. So 6 divided by 2, that's 3 times 1. So 3. And then for 1/3 is equivalent to 6 divided by 3, that's 2 times 1, 2. So we write, so instead of writing 1/2, we write 3 over 6. And instead of writing 1 over 3, we write 2 over 6. After that, we factor out 1 over 6. Or we can write this 3 raised to 3 raised to 1 over 6, 2 raised to 2 raised to 1 over 6. And then we remove the exponent 1 over 6. We put it outside. Ayan. So, after that, we can now write this as, if you recall, if you have 1 x raised to 1 over n, this is the nth root of x. So, our index now is 6. So, the 6th root of 3 raised to 3 times 2 raised to 2. If we will simplify, we have the 6th root of 27 times 4. Multiplying 27 times 4. So, this is the 6th root of 108. Next example, let us have these radicals. First, write them using rational exponents. 5 raised to 1/2 times 6 raised to 1/2 times 7 raised to 1/3. Notice that they have different bases. Next is, we write the fractions in such a way that they have the same denominators. So 1/2 and 1/3, their LCD is 6. So 1/2, this is equivalent to 3 over 6. 1/3 is equivalent to 2 over 6. So we write 5 raised to 3 over 6, 6 raised to 3 over 6, 7 raised to 2 over 6. Next, we write the rational exponents in such a way that we have 5 cubed raised to 1/3. Take note that from the property a raised to m raised to n is equivalent to a raised to m multiplied to n. We just factored the exponents. We just separated the exponents. And then 6 raised to 3 raised to 1 over 6 and 7 squared raised to 1 over 6. Next, we write 5 cubed times 6 cubed, 7 squared. And then we have here 1/6. It's like we are applying the properties of exponents backwards. 1 over 6, 6 will be the index. So 6 root of 5 cubed times 6 cubed times 7 squared. If we are going to multiply, we have 5 cubed, that's 125 times 216 times 49. So we have 1,323,000. So this is our final answer.